So when we're trying to factor quadratics that have a lead coefficient other than 1, we can't just use the diamond like we have in the past. We can't just say, okay, what multiplies to get us 6 but adds to get us negative 17? Well, first off, nothing does multiply to get you 6 and add to get you 17. That doesn't work here. The reason that always worked in the past is because the lead coefficient was 1, and we didn't have to care about trying to multiply to get anything else. So, for these, it's going to be a little different. It's almost just a game of guess and check, honestly. So we're trying to figure out the first spot, what multiplies to get you the first number. So we like when the numbers are prime, because the only thing that's going to multiply to get you 5x squared is 5 times 1. So it has to be 5x and 1x. So that multiplies to get you your first number. The second spot has to multiply to get you the last spot. So what times what is 6? So this is where you kind of have to guess and check a little bit. So what are some factors that multiply to get you 6? 1 and 6, or 2 and 3? So let's try, for instance, 2 and 3, but I'm going to try to put them specifically in the wrong spot. So if we do 3 and 2, how we check is that they have to, the combinations have to add to get you that middle term. So let's see here. 3 and 1, so that would be 3x. 5 times 2 is 10. So 10 and 3 does not add to get you 17. So this is not correct. So let's try if we switch it 2 and 3. So then if we check again, this would be 2x. 5 times 3 is 15. So can we get to negative 17 using 15 and 2? We would want them both to be negative. And then a negative 2 times a negative 3 is positive 6. So 5x minus 2 times x minus 3 is the factored form of that expression. And again, you guys can always check your work. Like if you guys multiply it back together, 5x minus 2, x minus 3, it should get you back to what you started with there. So let's try some more. So I'm going to have you guys try 2. I'm going to do 3. So 6x squared plus x minus 15. So what times what gets us 6x squared? I'm going to do 3x and 2x. So when it's not prime, so 6 is not prime because you can do 6 and 1 or 2 and 3. It's usually not the number itself and 1. 80% to 90% of the time it's going to be the factors other than the number itself and 1. So if you're using a guess and check here, I would start with 3 and 2, not 6 and 1. So 3x and 2x. So what multiplies to get us 15? 15 and 1, 3 and 5. So same thing again. It's sort of a guessing game. And you're probably not going to use 15 and 1. Not unlikely or not a possibility altogether, but not likely. So sometimes I write them just littler. So like if I just check 3 and 5. So if I check that, that would be 6. 3 times 5 is 15. So 15 and 6 doesn't get us to 1. So what if I did 5 and 3 the other way? 5 times 2, 3 times 3. So can we get to 1 using 10 and 9? Do we want 10 minus 9 or 9 minus 10? 10 minus 9. So 3x plus 5 times 2x minus 3 is the factored form of 6x squared plus 1x minus 15. So let's just keep going here. So 9x squared minus 64 So I don't know if it's helpful, but you can put a filler term in the middle there for your b. So if there's no x term, you can write 0x if that's helpful to you. So here's the thing with a binomial, like two terms where you have a 0 in the middle. If you have a 0 term, these two numbers have to be the same but opposite sides. So it has to be like a -4 and a +4, or a -3 and a +3. That's the only way that you're going to add to get 0. So these numbers, and your first term too also has to be the same number but opposite, because it's a difference of squares. 9 is a perfect square. 64 is a perfect square. So what times what is 9x squared? 3x times 3x. What times what is 64? 8 times 8. This gives you 24, 24. So we want 24 minus 24, right? So we want plus and minus. So when you have a difference of squares and that middle term is 0, you need to have the exact same terms in both your factors, just 1 plus, 1 minus. Nothing, again, that you really have to memorize, but it's a good thing to look for. So when you see two perfect squares and no middle term, know that it's a difference of squares. So let's look at number 5. 4y squared plus 20y plus 25. So what times what is 4y squared? 2y times 2y. What times what is 25? 5 times 5. This would be a perfect squared trinomial, because it's going to give you, or you're going to use the same exact factor twice. This gives you 10, this gives you 10, 10 plus 10 is 20. So you can write them out as 2 separately, or since they're exactly the same, you could write them out as 2y plus 5 squared. Doesn't matter which way you write it in there. Okay, let's keep going. So let's look at number 6. 36w squared minus 12w plus 1. Again, perfect squares there. So this is another perfect square trinomial. But what gets you 36w squared? 6w times 6w. What's the only thing that multiplies to get you 1? 1. So we need -12. So we want -6 and -6. -1 times -1 will give you a +1. Okay, 7, 8, and 9. The first step you always want to take when you're factoring is checking to see if you can pull out a common factor. If you don't pull out that common factor, if there is one at the beginning, and you leave it in there as in your final answer, it's not going to be factored completely. So the rule of thumb is really to just check before you even start if you can pull a GCF out. Otherwise, you'll always have to check at the end. So I've just known so far for 1 through 6 that there haven't been any common factors to pull out, but 7, 8, and 9 are specifically designed to do that. So like if we're looking at 5x squared and 45, in this case, you couldn't actually factor it until we pull out the GCF. But 5 and 45, a common factor you could factor out would be 5. So 5x squared divided by 5 leaves you with x squared. 45 divided by 5 leaves you with 9. So that 5 doesn't go anywhere. I'm just going to sort of put it in parentheses, and I'm going to put a filler in there for my b term or my x term. So now we're going to factor this trinomial. So similar to number 4, these are two perfect squares, 1, x squared, and 9. 0 term in the middle. This should be a minus. So 5 stays. What multiplies to get you guys x squared? X times x multiplies to get you 9, 3, and 3. So we want a plus and a minus so that this equals 0 in the middle there. And if you would have left that 5 in there, it wouldn't have been a difference of squares because you don't get the squares until you factor the 5 out. So sometimes you have to factor out that GCF first, but regardless, that should always be your first step. Check to see if you can pull a common term out first. So, similar with number 8, can we pull out a common term from 6, 14, and 8? They're all even, correct? So we can factor out a 2. So when we factor that guy out, it's just dividing by all of them. So 6 divided by 2, it's going to leave you with 3, q squared still. Negative 14 divided by 2 leaves you with negative 7, q still. 8 divided by 2 leaves you with 4. So now we'll try to factor this guy here. So what multiplies to get you 3q squared? 3q and q. 3 times 1. What multiplies to get you 4? So let's see, 2 and 2. That would give us 2q. That would give us 6q. So 6 and 2, we can't really get to 7, so that's not going to work. And I can't just switch 2 and 2. So it must need to be 4 and 1. So what if I do 1 and 4? Does that work? 1. Q 3 times 4 is 12. That doesn't work. So it must be the opposite way here. 4 and 1. So that will give us 4. 3 times 1 gives us 3. Does that get us to 7? Yes. They both need to be negative. So it might take a minute or two till you get to the correct combination. But that's just why I write them smaller. I would use pencils so you can erase. It's just getting that right combination to get you to the original trinomial there. Okay, so let's look at number 9. Can we pull out common factor there from 12, 21, and 3? Yes, we can factor out a 3. So that leaves us with 4p squared, 7p, and 3 divided by 3 is not 0. 3 divided by 3, number divided by itself is 1. So now we will factor that guy. So 3. So what multiplies to get us 4, but adds to get us 1? We can do 2 and 2. We have to do 1 and 1. Okay, so this would give us 2 and 2. That doesn't get us to 7. Okay, so what if we change it to 4 and 1? Well, this would give us 1. This would give us 4. Still doesn't get us to 7. So in this instance, guys, factoring out that 3 was as far as you can go. So I don't want you to say it's not factorable, because it is factorable. You factored out a 3. It's just not factorable further past that, which is sometimes the case. But for these, it's just a matter of getting the right combination. So what multiplies to get you the first number goes in that first spot. What multiplies to get you the second number, or the last number, goes in your second spot. They have to add to get you the middle. So why don't you guys try number 2?